Hello everyone, welcome to Belgar University. My name is Anders. I've been in the industry since 1995 and in particular dealing with AquaPave since the early 2000s. In today's session we're going to do a quick introduction into the AquaPave system. In my opinion, the most complete permeable system on the marketplace. Basically, like every other system out there, when properly installed, we will deal with stormwater. But the reality with ours is because of the InviTex geotextile that we have that is patented to our system, we're taking out to 97% of heavy metals out and up to 99.9% of hydrocarbons. So basically at that point you're getting gray water. This gray water can be used for lavatories, irrigation. There's even systems out there where they've introduced a sump pump and they're using the water for car washing. So there's all kinds of applications for this. So as we all know, renewing water is important to all of us, helps our streams and banks and erosions and everything else we're doing. So this is part of a goal moving forward for all of us. We've been dealing with this since the early 2000s. At one time we had the largest job in North America, the Marineway Mall at 450,000 square feet. Went very, very well. From there we've done some other jobs, not quite as big as that one, but I got a strong foothold in the marketplace, and typically landscape architects like to specify the AquaPave because of all the components that we bring into the place. Like I said before, we've been dealing with this since 2000. Chris and I went back to England, went to see Professor Chris Pratt at Coventry University, reviewed the research they were doing there, saw the numbers, saw the reality of the product and what difference the InviTex was making in their test results. And we signed on at that point to bring it to North America for FormPave located in England. We've had it here since 2000, been going very, very well. Of course, now we come back to Canada, we've got a great system, and we're hearing some negative reviews over the permeable pavers that have been in place already. The negative reviews were that these weren't being installed properly. So at that point, we figured, what are we going to do? And the answer was to talk to our dealers, contractors, and the owners of these projects and say, how can we help you do this? The idea was to create a program, and the program basically would show contractors what the system needs to look like, how it needs to be installed, how to do best practices with this program, and go from there. And what we do, tie it all together with a little bit of an exam at the end to make sure there's a good retention of the knowledge that we've been giving them, and they understand what the program is. And that's gone very, very well. And so the video you're going to see is part of that program. It gives you a bit of an introduction to everything, shows you some of the bigger projects that have been completed, including Marineway Mall and University of Victoria, several projects over there. At that point, we do offer the virtual exam. That will happen, first one will be April 16th, and we are going to do that moving forward. Allows us to do smaller groups more easily than in the old days, so that'll be an improvement. If there are any questions at the end of this thing, please feel free to contact me or any of the team over here at Abbotsford Concrete or Expo Crete or Belgard. Thank you.
The AquaPave system is a science-based real-world solution in our struggle to balance economic development with environmental stewardship. The AquaPave system allows commonly recurring rainstorms to infiltrate through a permeable concrete surface into an open graded crushed stone base before being released into storm sewers or watercourses. Known as permeable interlocking concrete pavement, the system acts as an infiltration facility for the storage, treatment, and improvement of released water quality. In conventional drainage design, infiltration and detention facilities are separate from impervious parking lots and pedestrian areas. AquaPave combines the parking, infiltration, and detention facilities into one location, allowing more space for income-generating buildings. For some designs, there can be cost savings realized from decreasing or eliminating drains, inlets, oil separators, and utility structures. Additional savings can be realized by using the AquaPave geothermal system. It is capable of reducing a building's reliance on gas and/or electricity for heating and cooling by up to 50%. This patented system for heat capture from stored water can generate 6 kilowatts of energy for indoor climate control from approximately 100 square meters or 1,100 square feet of AquaPave. Roof water can also be discharged into this sub-base as well. AquaPave's patented design was created to accommodate most vehicular applications and all types of pedestrian traffic areas, including low-speed residential roads, parking lots, inspection areas, driveways, bicycle paths, building entrances, and walkways. Municipalities strive to manage runoff from a range of storms, with the intent of reducing runoff volumes and peak flows to those of pre-development conditions. The majority of applications for permits now must include post-construction best management practices for the reduction of runoff and pollutants. AquaPave provides the perfect solution. Unlike other permeable pavers, the AquaPave system does not incorporate loose aggregates on its surface, making it safer and more comfortable to walk on, even in high heels. AquaPave paving units have gaps less than 13 millimeters wide and a pedestrian slip resistance that meets the guidelines recommended by the Americans with Disabilities Act. Since AquaPave isn't required to be sloped for drainage, it is a very pedestrian-friendly surface. AquaPave permeable pavers have the same aesthetic and structural characteristics as regular concrete pavers, including the range of colors available. A vehicular skid resistance equivalent to or better than asphalt surfaces, and a design life equivalent to that of conventional interlocking concrete pavements, typically 30 to 40 years. Should the pavers become damaged, they can be removed and replaced. The AquaPave system is very low maintenance. However, sediment that collects in the surface openings should be removed by vacuum equipment at least twice a year. In the event that outflow rates become significantly diminished, the pavers are simply removed, the bedding course and InviTex placed, and the pavers reinstated. Since the contaminants are trapped in the InviTex layer, this can be done without disturbance to the upper or lower subbase. This is not possible with other systems. Typically, filtered and treated water exiting the AquaPave on-site stormwater source control system can be reused for non-potable uses such as domestic or commercial irrigation. Availability of air and water to root systems are key to the survival and growth of urban trees. This is usually accomplished with the use of a grate or an irrigation system. AquaPave has been successfully used with load-bearing tree soils. This now enables hard surfacing to be used right up to the border of the tree pits. AquaPave and structural soils allow air, water and nutrients to reach the roots, which is not possible with conventional paving. The Leadership in Energy and Environmental Design, LEED, uses a point rating system to recognize environmentally conscious site and building designs. The AquaPave on-site stormwater source control system is eligible for earning upwards of 12 points. AquaPave, an exciting development towards a greener, more sustainable future. AquaPave, a paving system we can all live with. As with any type of construction, the initial step is the design and engineering necessary to compensate for existing site-specific soil conditions. It is very important that the installation contractors follow the predefined engineering specifications and checklist outlined in the AquaPave product manual. Any deviation from these specifications should be completed by a qualified engineer to ensure that the long-term integrity and functionality of the AquaPave system is not compromised. The area to be paved is excavated according to engineered specifications, ensuring that any organic material is removed from the subgrade. Once the excavation is completed to specification, the stormwater control APSC 1000 geotextile is rolled out over the entire surface of the subgrade. The geotextiles of the AquaPave permeable paving system are integral to its strength, pollutant removal and overall effectiveness. Therefore, it is important to follow these simple installation guidelines. The geotextile must extend up the sides of the excavation to exceed the height of the finished surface of the pavers. This prevents contamination from entering the open graded aggregate base, maintaining the void ratio capacity. This includes all catchments and utility structures within the excavation as well. The adjacent rolls must be placed so that there is a minimum 12-inch downslope overlap at the joints, or as specified by the geotechnical engineer. To help prevent movement of the AP-SC1000, it is recommended that the geotextile is secured either by placing sandbags or driving fasteners into the subgrade. After the AP-SC1000 geotextile is securely placed, the lower subbase layer of 2.5-inch clear crushed fractured aggregate with no fines, ASTM number 2, or commonly referred to as rail ballast, is carefully placed to the desired depth. This depth will vary with the site-specific requirements, as determined by the geotechnical engineer. All base materials provide a void ratio of approximately 30%, which maintains the structural integrity and provides the required water storage capacity. When placing the lower subbase, care must be taken not to wrinkle or fold the geotextile. Once the lower subbase is graded to the desired elevation, it is compacted with a minimum 10-ton vibratory roller in 4 to 6-inch lifts. The lower subbase must be compacted to a minimum 97% modified Proctor density before placing the upper subbase. In certain applications where the project may experience a weak subgrade or may encounter heavy traffic volume, layers of SC intergrid reinforcement geogrid should be incorporated into the design. This will mitigate the radial stress imparted from a traffic surface and uniformly distribute the load. The implementation and installation of the SC intergrid will be determined by the geotechnical engineer. Upon final compaction of the lower subbase, 4 inches of 3/4-inch clear crushed aggregate ASTM number 56 is then applied. The upper subbase is graded to the required elevation and compacted in the same manner as the lower subbase. It is critical to ensure the side of the edge restraint adjacent to the paver is perpendicular to the bedding course. This ensures a tight fit, locking up the system and eliminating trip hazards. Once the paver restraint is in place, the 3/4-inch clear crushed upper subbase can be graded to its final elevation and compacted. InviTex was specifically designed for the AquaPave system. This unique geotextile not only acts as a filter that collects pollutants as they infiltrate through the pavement, but also creates an environment where microorganisms are fostered. This microenvironment is capable of reducing the pollutants that are trapped into harmless organic material. It is therefore possible to bioremediate the AquaPave system without disturbing the lower and upper subbase by simply removing the InviTex and bedding course. This is not possible with other systems. When the upper subbase is sufficiently compacted, the InviTex geotextile is rolled out over the entire surface using the same technique as with the AP-SC1000 geotextile. As with the AP-SC1000, the adjacent rolls of InviTex must be placed so that there is a minimum 12-inch downslope overlap at the joints. The InviTex geotextile must also run up the sides of the paver restraint to exceed the finished surface of the pavers. This very important step is necessary to sustain the microenvironment created by the InviTex layer by avoiding contamination by foreign materials. The excess InviTex is trimmed to the surface of the pavers after final compaction is completed. A 2-inch bedding course of 1/4 inch clear crush aggregate ASTM number 8 is carefully placed on the InviTex. Care must be taken not to wrinkle or fold the InviTex while spreading the bedding course. It is recommended that the bedding course be spread by mechanical means, such as a slinger, whereby the bedding aggregate is applied directly to the surface of the InviTex. If trucks are required to dump their loads on-site for subsequent placement, it is essential that a temporary barrier, like sheets of plywood or geotextile, be placed on the dumping site surface. This will prevent contamination caused by the mixing of aggregates or other foreign material, which will choke off subsequent layers, reducing permeability and void ratio content. Screed rails are placed to ensure finished elevation of the bedding layer. A 1/4 inch clear crush bedding course is then lightly compacted with a plate compactor. The final screeding sets the finished height of the paver. Allow enough surcharge around paver restraints and utility structures to eliminate trip hazards due to compaction and settlement. Whether the project is being installed by hand or by mechanical means, AquaPave pavers are delivered to the site on pallets, ready for installation. On larger projects, when mechanical laying equipment is used, the pavers are manufactured and shipped in the pre-arranged laying pattern. This type of installation is less physically demanding on the installers, allowing a standard crew to install upwards of 10,000 square feet per shift. This type of installation can be very cost-effective. The AquaPave pavers are cut to fill in the edges. All cuts must be made with a masonry saw to ensure maximum contact between the cut edge of the paver and the edge restraint. No paver segment shall be smaller than 1/3 of a full paver. Modification of adjacent full pavers to a half or 3/4 of their original length is allowed. In some standard interlocking paver installations, guillotines or paver splitters are used to make cuts. This type of cut is made with a taper towards the back of the paver, which creates a void which cannot be filled by the joint stabilizer material in the AquaPave system, as it would be by sand in a regular paving stone project. This prevents you from achieving paver interlock. Pressures created from vehicle traffic exert point loading stresses on the cut edge of the paver. This will eventually result in breakdown from fatigue. This breakdown will result in creep, leading to a loss of interlock and system failure. After the paver installation is complete, an initial compaction is required. A low amplitude 75 to 90 Hz plate compactor capable of at least 5,200 pounds centrifugal force should be used. Once initial compaction is complete, check for any damaged pavers and, if required, remove and replace them. We can now lock up the system by spreading and sweeping in the AquaPave engineered joint stabilizer, completely filling the joints. It is necessary to sweep off the excess joint stabilizer before continuing compaction to eliminate unwanted marking of the surface of the paver due to the coarse nature of the joint stabilizer. 2 to 3 more passes with a compactor will be required to complete the project. Unlike a typical interlocking paver installation, AquaPave joints are not required to be completely filled after final compaction, but the joint stabilizer should come within a 1/4 inch of the paver surface. The paved area is now available for immediate use. AquaPave, an exciting development towards a greener, more sustainable future. AquaPave, a paving system we can all live with.
you enjoyed the video. Thank you for tuning in. Once again, if you have any questions, please do not hesitate to contact us. Our role out there is to try and help everybody do a more complete and better project. Thank you.